Hello, and thank you for joining. My name is Andrew Skalkin, and I'm the founder of Datagrok, a next-generation data analysis platform. You might ask, why do we need another platform at all? And that's a good question. In my previous life, so to speak, I've been with Johnson, where I've been wearing multiple hats, and I've been both implementing, developing analytical solutions and using existing ones. So I'm quite familiar with the limitations and pain points associated with them. Eventually, we realized that by making a clean break and utilizing the latest technologies in a novel way, it is possible to build a solution that would be on a completely different level, that would allow us to essentially leapfrog the competition. So Datagrok is our answer to that challenge. So let's look at some of the pain points and our solutions to that. The platform is enterprise ready, and at the same time, it has a heavy emphasis on life science and biopharma. It could be used as either a self-service analytical platform or a platform for building custom solutions on top of it, and everything in between. In the second part of the presentation, Nick Stiefel from Novartis will describe how Novartis built a custom solution on top of the platform. So our goals are pretty ambitious, and the way we achieve them is by making technological breakthroughs. One of them is our proprietary technology that lets us work with tens of millions of data points completely in the browser. And we reuse the same technology across our whole technological step that makes the platform really fast. So we aim to provide completely seamless access to all the different data silos in your organization. The platform is also extremely fast by utilizing the in-memory data engine. You'll see it later in the presentation. Moreover, the visualizations are domain aware, so you would see molecules on scatter plots, p-values automatically calculated for box plots, all sorts of regression lines on scatter plots, and so on. We really take scientific computing to the heart, and we provide first-class integration with scientific languages such as R, Python, Julia, MATLAB, or others. The platform provides out-of-the-box no-code predictive modeling, meaning you can ingest, analyze, build predictive models, assess them, and deploy them without having to write a single line of code, which is extremely powerful. All of the capabilities that I mentioned also allow us to provide things like data augmentation and data dissemination and knowledge dissemination, meaning that it's possible to provide different contextual projections of the data sets you are currently looking at. On top of the platform, we have also provided a number of support for a number of different domains, such as cheminformatics, bioinformatics, digital health, or machine learning. The platform is extensible by design, and it has an open source ecosystem of extensions. Slides don't do Datagrok justice, so let's analyze some data. Retrieving data from a database is as simple as navigating through your databases, through the schema, down to the tables. It's possible, the platform gives you instant preview of what's inside. In this case, we are looking at the Campbell dataset and notice that the molecules are rendered right on the fly. If we were to open files, you would get instantaneous preview of what you are looking for with a on-the-fly profiling for different columns. The platform also supports multiple scientific data formats and has support for bioinformatics, cheminformatics, and other domain areas. Opening a local file is as simple as drag and dropping a file, or you can open it through a dialog. It opens in less than a second and gives you an interactive view that can be interrogated. In this case, we are going to filter some data on the fly, color code it differently, introduce more filters, and analyze different distributions based on age. Even in this case, we see multiple patterns emerging as we simply scroll the data. With that, I think you got an idea of what the platform is, and I'm happy to pass the stage to Nick. Thank you.
Thanks, Andrew. I'm Nick Stiefel. I'm from Global Discovery Chemistry from Novartis, and I would like to introduce you to Intuence Discovery, which is the first product in our Intuence product suite. What we have with Intuence Discovery is that we want to build a fully integrated data analysis and reporting product. And we're targeting non-experts. This is very important. This is not for the data scientists, but really the bench-side chemists. And what we want to achieve is a common look and feel, as well as a seamless navigation and data flow between the different products. Why Intuence Discovery? In the end, it's three major points. We want to democratize data analysis. We want to integrate and connect the different applications and remove data silos, and also streamline the workflows across the full drug discovery phases. So really have one tool that covers it from, let's say, target identification towards a candidate in the clinic. Impact-wise, we know that we will have a faster decision-making based on something like this. We will better use our resources, especially in terms of assay submissions to relevant assays. We will enable future technologies, and we have some early proof for this, especially in the machine learning space. By bringing everything together, it's much easier to actually make the connections, and also guide other data initiatives, especially about what are the data pieces that we cannot properly show for analysis that then need to be improved over time. Why Datagrok, you might ask? So for us, the highest aim was really to innovate, but not reinvent. We have a current POC product, which is called IGPS, that's built on a FAT client. And out of this, we had some key requirements. We needed a native web-based, extensible, and really high-performant application. It had to be attractive for the end user and really interconnected to our other tools to avoid user frustration and really have the high pickup. We needed some domain functionality, especially in the chemistry space, and it also had to be future-proof, right? We want to build on this for the next couple of years to really have impact for the organization. The way we achieve this is that essentially we only have a very little area for user input. So essentially we just pull the data from systems that the users use already to define their project essays, the queries, the ideas, and also the annotations. We then inject common essays that everybody or every project team is using. We pull all this data together. Then we start aggregating, reformatting, and also annotating with things like chemistry enrichment and so on. Then we have live data on each load. So it's fresh data every time. And as you've seen from Andrew, it's super fast once the data is loaded. Now, a short video on how this looks like in real life. You just essentially define your analysis name. You can vary your access and your contributors. You just specify your queries for the compounds, for the virtual compounds, and things like your project essays. And then finally, you can have your component series. That essentially means chemical annotations of your series that you have in your project. You can see here, this is a public data set with cephalosporins. And then once you have the data, it's a very wide table for us. Only the first part here is essentially project specific. This is the chemical enrichment, R group decomposition. Then we add the measured data of typically ADME properties and things like this. And then finally, there's also information about our global models that people use for the optimization of their compounds. And here's something that you've seen slightly from Andrew already. We're using the native Datagrok viewers and the filter panels. We work very closely with the Datagrok team to make sure that we get really the best out of the Datagrok underlying platform. But we also extended. There is something called the data grid, which kind of allows you to visualize compounds in a way that is very common to how our internal presentations look like. You can modify these, customize them. You can reorder things. This is a very first basic version. There's some color coding, traffic light schemes. You can add assays as you need. And then essentially this allows the user to really save a lot of time overall when they prepare for team meetings and so on. And then one last thing, this is the connection to the outside world. If you want a tool called CAST, which is our idea annotation tool, so you can just, while you're analyzing your data, while you're in a team meeting, select compounds and then modify the status for these or the synthesizer. In this case, the status, you can see, you switch it over to proposal, it talks to the backend system, and then just returns a notification to the user that everything went well. And of course, this is done by a bigger team. This is the team. I need to mention here that it's really a strong collaboration between our research IT department, and Mark already introduced this a little bit, and the business, our chemistry, but also TM and other parts of the organization, and of course with Andrew and his team from Datagrok. And with that, I thank you very much for your attention, and I'm awaiting questions.